So kahapon po, we have discussed yung syllabus, and one of the discussion is simply the definition of machine design. Okay? So today we'll have our Module 1, okay, which defines the essence of designing. Okay, so we start first with the definition of the machine design. Okay, so ano po ba yung tinatawag natin na machine design? Okay, pag sinabi po natin na design, we are after finding the suitable dimensions. Okay, so we are after the most suitable dimensions. Alin po ba yung suitable dimension and appropriate dimension? Okay? For us to pick yung tamang dimension, okay, alin po yung dapat natin na i-follow? First, we have to satisfy the strength requirement. Okay? Yung pangalawa po is yung pong ating economics. So, ito na yung kanyang pagkakasunod-sunod. Okay? Ito muna po strength requirement bago po yung economics. So, bawal po natin siya na pagbaliktadin. Okay? So, ito muna po. So, when you say strength requirement, ano ba yung dapat natin na i-consider dyan? We should know all forces that must be carried noong ating dinidesign na structure. Okay? So, halimbawa po, we have the wire rope. Okay? So, for the wire rope, and say gagamitin po natin siya for a cable car. Okay? So, I know all of you naman po are familiar with a cable car. Okay? So, to run this, you have yung wire rope para i-run po iyon. Okay? So, how do we design the dimension of this wire rope? Ano po yung mga kailangan natin na i-consider? Okay? So, ito po yung ilan. First, you have there po yung atin na cable yung cable car mismo. What would be the weight of the cable car? Okay? So, dapat po alam po natin yan when we design the member. Pangalawa would be the capacity. Okay? Ilan ba yung pwedeng gumamit ng atin na cable car at the same time? Okay? So, ano yung kanyang capacity? And then, if it will have yung ating mga tao na sasakay doon, kung ilan yung capacity niya, and ano yung mga, ano yung weight niya. So, what would be the total? Okay? So, yan po yung ating i-consider. The other one is, yun po, gravity. Okay? So, yung effect po ng gravity tuon sa atin na structure. Okay? And then the last one would be, yun po, wind resistance. Okay? So, yan po ay ilan lang sa mga factors that we need to consider na kasama dito sa strength requirement. Okay? So, titingnan po natin yung mga yan, okay? For us to be able to know, okay, ano pa yung tamang dimension na ating pipiliin. Okay? So, dapat makita natin lahat ng factors that could affect yung kanyang performance. Okay? So, that would be the strength requirement. Kailangan muna po ito masatisfy before we go on to the next factor po natin. Okay? So, bakit po kailangan na masatisfy yan? That is, of course, to incorporate po yung safety. Okay? So, hindi po pwedeng pabayaan na lang natin. Otherwise, ay anong mangyayari sa structure natin? It will fail. Okay? At yun po yung iniiwasan natin. That could lead to yung accident po. Okay? So, another thing is, when we consider the strength requirement, meron po tayong tinatawag or idinadagdag dyan na allowances and tolerances. Okay? Parang yung sa mga damit po natin. Okay? Di ba yung sa damit, nakikita mo, ay mayroon siyang allowance. Okay? So, ganun din po when we design for the structure. We provide allowances, tolerances, we incorporate po factor of safety. Okay? So, ibig sabihin po niyan, yung ating structure can operate doon sa kanyang maximum capacity, okay? Pero meron pa ring allowance, okay? So, ibig sabihin, hindi ka mag-aalala na, ay, maximum capacity na, baka bumigay ito, okay? Kasi meron kang allowance pa, okay? So, yun po yung andito sa strength requirement. Yun po yung kasama dito, okay? So, pag na-meet lang po natin yun, we say yung dimension natin would be sufficient enough to meet yung strength requirement po na yun. Okay? So, that is the first one. Now, suppose you have there tatlo pong material. So, A material, B material, C material. Okay? So, tatlong materials yung pagpipilian natin. Okay? Kung ang tatlo pong ito, okay, na-satisfy na yung strength requirement natin, okay, tsaka lang po tayo pupunta doon sa pangalawa po natin na requirement. Okay? So, you need to compare po yung tatlo na yan. Okay? Pare-parehas po nakasatisfy sa strength requirement, i-compare mo ngayon. Okay? What would be the operating cost kung ang gagamitin ko ay material A? What is the operating cost kung ito yung aking material, yung B or yung C, okay? So, you now compare po yung available materials. Whichever will lead to yung mas pinakamababa po na operating cost, yun po yung pipiliin natin ngayon. Okay? So, yun na po yung pangalawang factor na economics. Okay? So, kasama po yan sa pagpili natin ng tamang dimension, ng suitable na dimension. Okay? But then again, bago po natin tayo pumunta dito sa pangalawa po nating factor, dapat yung masatisfy mo na po yung strength requirement. Okay? Now, so bakit po kailangan pa yung economics? Okay? So, we need here, okay, we are after, of course, what we call the profit. Okay? So, need pa rin natin yung profit. So, if in the future you are hired as a design engineer, yan po yung gagawin ninyo. Okay? Strength requirement first, and then bakit ka in-employ? To make profit for the company. Okay? Of course, yung company naman po hindi yan magsusurvive kung wala siyang profit. Okay? But then, take note that yung profit lang is pangalawa pa lang yan. Okay? Ito muna. Otherwise, anong mangyayari? Posibleng magkaroon ng hindi maganda. Okay? Kaya ito, kinoconsider natin once ito ay nasatisfy. Okay? Now, so considering A, B, and C halimbawa, okay, parehas na siya naka-strength requirement, yung may pinakamababang operating cost po, yun po yung pipiliin natin. Pagbaba po ng operating cost, mas mataas po yung magiging profit po natin. Okay? So, in order for the company to survive, dapat meron din naman tayo na profit. Okay? So, ang kinoconsider dyan is, halimbawa, A is locally available, B is inaano pa natin, ini-import pa natin. Okay? Of course, mas lamang yung A. Okay? Kasi, it is readily available. Kapag pinili po natin yung B, there would also be a shipping fee, okay, wherein madadagdag pa yun sa iyong operating cost. Okay? So, those that are readily available, mas pinaprioritize natin. Okay? Same thing, we also consider yung ease ng paggamit. Okay? Kumbaga, is user-friendly. Okay? Maari naman na hindi siya user-friendly and you need a lot of attachments or accessories needed bago siya magamit. Okay? So, or a lot of processing na mangyayari. So, hindi pa rin ka makaka-benefit doon ng madaming profit kasi ang mangyayari doon is you need to go over those processes that will entail additional cost pa din. So, dapat tinitimbang-timbang natin. Okay? Alin ba dito talaga yung magli-lead sa pinakamababang, okay, operating costs. Okay? Kasi nga, satisfy na nila lahat yung sa strength requirement. Okay? So, ganun po pinipili yung atin na right dimension or suitable dimension for the machine member. Okay? Now, sa atin po na klase, okay, we will incorporate din po ito. But then, sasabihin natin, ay, paano yung ma'am yun i-incorporate? Wala naman tayong magiging cost estimates. Wala naman po tayong pupunta at bibilhin. Okay? So, paano po natin may incorporate yung economics po na yan? Okay? So, again, it is by the use of the commercially available size or the standard sizes. Okay? So, in that way, kahit po sa computation natin at yun yung ginamit natin, nag-a-adhere po tayo dito. Okay? We are considering yung economic side po na yun. Okay? So, why? Kasi pag bumili tayo ng material, you would have there the initial cost. Okay? Halimbawa, katulad ng sample natin kahapon, diameter, say, through computation, we arrive at 2.35 inches. Yan. Okay? So, pag binili natin, okay, that is the initial cost of the material. Wala tayong mabibili na ganyan. Okay? Ganyan na size. So, what is available would be, say, 1 and 1/4, 1 and 1/2. Yan. Yan po yung mga available sizes in inches. So, ang bibili natin, of course, yung pinakamalapit. Ano yung pinakamalapit? Yung 1 and 1/4. That is 1.25. So, pag binili mo yung material, that would be the initial cost. Okay? And then, ano po ang sunod? If you insist on using this, so dadalhin mo siya sa machine shop. So, gagawin natin, i-run sa lathe machine para mabawasan yung kanyang diameter. Okay? Making it 1.235. Okay? So, doing that, you would have the fabrication cost. Okay? So, the initial cost plus the fabrication cost. Okay? So, bagsak na po yun dito. Okay? Kasi nag-additional cost ka po noon. Okay? So, bagsak po siya dito. So, ano po yung dapat nating gawin? Okay? So, ang gagawin po natin, kung ito yung binili natin, you let it as it is, yung 1 and 1/4. So, in that way, na wala na po itong fabrication cost, we only have there the initial costing. Okay? Ang tanong ay, bakit po ma'am yan yung gagamitin? Diga nga po sa aking computation, it should be 1.235 inches. Okay? Bear in mind that this value, this is the minimum allowable. Okay? This is the minimum allowable. Ibig sabihin, pag baba niyan, okay, pag bumaba sa value na yan, hindi na siya safe gamitin. Okay? Maari ng yung failure, makita na natin. Okay? So, maari nang masira. Okay? Yung structure mo. Kasi this is the minimum allowable value. Okay? Pero pag pinalaki natin dyan, okay, ibig sabihin, mas magiging safe po siya. Okay? So, if you will be using 1 and 1/4, then this is much safer than dito po sa 1.235. Okay? Kaya hindi ka na po gagastos na ring fabrication cost. Only the initial costing. And at the same time, mas safe pa po siyang gamitin. Kasi mas malaki yung dimension niya as compared to what you have computed. Okay? Kaya yun po yung pasok dito sa pangalawang factor po natin. Okay? Gagamitin mo na lang is the commercially available size. Maliwanag po ba? Hello?
Yes po.
Hello?
Yes po, ma'am.
Now, sabi niyo po ma'am, mas maganda kung mas malaki yung dimension. Okay? Pag nilaki po natin yung dimension, the safer it would be. Okay? May available po ma'am na 2 inches. Okay? O, pinili niya lang po is 1 and 1/4. Bakit po hindi natin piliin is yung 2 inches? Any reason for that po? Anyone? Hello? Oh,
Para
sino
po hindi tumaas yung initial cost po.
Okay, tama. Okay, so ayon kay Adrian, para hindi tumaas yung initial cost. Tama. Paglaki kasi ng dimension natin, mas malaki naman din yung amount. Okay, yung initial costing natin. Okay, samantalang, ito naman yung 1 and 1/4, safe na naman siyang gamitin. Okay, so mas mababa pa yung initial costing po niya. Kaya hindi rin po tama na gumamit ka naman ng sobrang laki. Okay? So, dito pa rin po yun, pasok doon sa second factor po natin. Okay? So, sa atin po computations dito, yun lang po yung magagawa natin para i-consider yung economic side. Okay? To change or to convert our answers, okay, the values, the dimensions into its standard size. Okay? Commercially available size. Okay? Again, yan po yung design natin. Okay? Which is very different from an architectural design. Okay? We are after the most suitable dimensions that would be used doon sa ating mga machine members. Taking into account the strength requirement and yun pong economics. Okay? So, yan po yung gagawin natin. Now, Let us have here po the essence of designing. Okay, this is the essence of designing. Okay, so for the essence of designing, we have here number one. Okay, we need to uh, memorize po this essence of designing. Okay, we have here 1 to 4 po. Okay, ito po yung number one. So, ito po yung fina-follow din natin whenever we do the design. Okay? So, number one is to know the property of the material. Okay? So, kilalanin po natin yung material natin na ginagamit. Okay? When you say know the property of the material, know it by code and know its strength. Okay? So, yun pong dalawa. Okay? Know the property of the material as to the code and as to strength. Okay? Yun muna pong code. So, yung code po, from our materials engineering po, we have the so-called AISI and SAE designations for steel. Okay? Yan po yung gagamitin natin na code dito. Okay? So, AISI and SAE designations for steel. Okay? So, these are two industries engaged in designating steel. When we say designating, you are naming the steel. Okay? So, you can determine the composition of the steel, okay, base po doon sa code. Okay? So, kapag po steel, pag sinabi po nating steel, this is mainly composed of iron. Okay? So, mostly iron po yan. Okay? Major composition niya po is iron. Then, you simply add alloying elements. Okay? These alloying elements, these are simply traces po. Okay? So, konti lang yung percentage na as compared to that of iron. Okay? And these alloying elements, it can be a single element na idadagdag mo sa iron o kaya naman po ay madami or combination of elements. So, we add these alloying elements to iron simply to enhance its property. And depende sa alloy na indinagdag natin yung magiging resulting steel, yung property ng resulting steel. Okay? So, some of the most common alloying elements po na dinadagdag natin, okay? Common po na nilalagay natin is nickel. Okay? Ano yung effect ng nickel? Okay? Ano po ba yung effect ng nickel kapag idinagdag natin siya to iron? Okay? So, yung nickel, that increases the strength of your steel. Okay? It increases also the hardenability ng steel po natin. Okay? So, the other one, we have their carbon. Okay? So, carbon, malimit din yung idagdag. So, ano naman po yung effect kung idadagdag natin yung carbon? Okay? The higher the carbon content, the more it will become brittle. Okay? Mas nagiging malutong yung atin na steel pag dami ng carbon na nilagay mo sa kanya. Okay? Another is yung chromium po. Okay? So, yung chromium naman, okay, yung dinadagdag natin yan to make a stainless steel variety. Okay? So, to make a stainless steel variety, ito po yung idinadagdag. Kasi halimbawa, application is on food, okay? Say, utensils, okay? So, kailangan, it should be rust-free, okay? So, we add there yung chromium. Okay? So, ito yung ilan lang sa mga alloying elements po natin. Okay? Again, traces lang po ng mga yan ang dinadagdag natin to enhance the property of the iron. Okay? Ito po yung major composition niya. Okay? So, kaya sa Tagalog po, ang tawag natin sa steel at sa iron, parehas bakal. Kasi nga, yun din naman siya. Traces lang ang ating idinadagdag to enhance the property. Now, the type of steel depends upon the alloying elements. Okay? So, dito sa mga alloying elements, halimbawa, may nickel siya, may carbon siya, may chromium siya. Okay? Kung alin po yung may pinakamataas sa kanyang percentage sa mga alloying elements, okay, yun po yung magiging tawag or type ng steel. Halimbawa, mas madami po ay doon ay carbon. Okay, so ang tawag sa kanya, it would be a carbon steel. Okay, kung madami po sa kanya ay nickel, dito sa mga alloying elements na naka-add dyan, so ang tawag natin sa kanya is nickel steel. But then, if you are to compare, okay, the percentage, okay, nung alloying element, kahit pa yung major alloying element, to the iron, ito pa rin po yung pinakamadami. Okay, ito po is, kumbaga katiting lang noong percentage ng iron po natin. Okay, so yan po yung doon sa AISI and SAE designations. They make use of the code. Okay, so mapapansin po natin, halimbawa, AISI, tapos may tatlong number, 23, 30, apat na number, 23, 30. So, yan po yung code. Okay? Yung code po na yan, it's defined by yung 4-digit na numbers. So, when you come across po sa mga bakal, huwag po nating isipin, ay, ito ay expiration date niya. Hindi po. Okay? It will determine kung anong alloying element ang present, kung anong composition meron po yung atin na steel. Okay? Yun po yung ibig sabihin. Now, let us recall again, ano nga ba yung AISI at SAE? So, these are two acronyms, okay, that defines yung atin na mga industries engaged in the designation of steel, okay? What is AISI? Yes or Dan?
Ano po? American Iron and Steel Institute po.
Okay, correct. So, tama po si Sir Dan. American Iron and Steel Institute. Okay, the other one, SAE. Yes, Eric.
Society of Automotive Engineers po.
Okay, so you have their Society of Automotive Engineers. So, wag po natin yung kakalimutan, okay? Pag nakita po natin yung mga ganitong codes, okay, yan po yung ibig sabihin. It defines the composition of your steel, okay? Doon po natin nalalaman ano bang meron siya, ano bang difference niya from the other one. And using those code po, doon din natin malalaman yung kanyang mga properties, okay? So, let us have now po sample nung designation, okay? So, we have here the designation. So, sabi ko nga po, it is defined by yung 4-digit na numbers, okay? So, katulad po nito, say, AISI, then 4-digit. So, say, ang sample natin kanina, AISI 2330. Yan, 2330. So, kada isang number po, i-represent natin in general as X. Okay? So, the first digit po, okay, refers to the type of steel. Okay? So, ang pwede po nating makuha dyan o makita dyan is from 1 hanggang 9. Okay? 1, 2, 3, up to 9. Okay? So, alam ko naman po na ito yung sa ulo nyo na kasi those who have taken up yung materials engineering sa akin, this is one of the items doon sa ating examination. Okay? And madami po yung nakakuha nito. Okay? So, kapag 1, it would be a plain carbon. 2, it would be a nickel steel, and so on. Okay? So, tauluhin po natin. Okay? Para alam natin yung composition. So, in this case po, AISI 2330. So, therefore, this one po is a nickel steel. Okay? So, this is a nickel steel. Yung second digit po refers to the percentage of major alloying element. Okay? Katulad po nung nabanggit ko kanina doon sa nauna na slide, okay? Yung steel po is iron mostly plus the alloying element. Okay? So, ang tawag po sa steel ay depende sa alloying element. Kung ano yung pinakamadami sa kanya, yun po yung tawag. Katulad po nito, kung pinakamadami sa tatlo is yung nickel, so ang tawag natin sa steel na yan is a nickel steel. So, we define this nickel as the major alloying element. So, here po, kung ang tawag natin dyan ay nickel steel, yung kasunod po na number would be the percentage of it. So, meaning this is nickel steel having 3% nickel. So, this is simply an approximation, okay? 3% of nickel. So, tingnan nyo po yung percentage na 3% lang, okay? Sabi ko nga, mostly yan pa rin po ay iron. Okay? Traces lang yung alloying element. So, lahat ng alloying elements, ito na yung pinakamadami. Okay? Yung nickel ang may pinakamadami. Kaya ang tao sa kanya, it's a nickel steel. Okay? And then the last two digits, okay, ito po ang pinakamahalaga sa design. Okay? This defines the points of carbon. Okay? So this one has 30 points of carbon. Okay? 30 points of carbon. And if you are to convert this into percentage, this is 0.30%. Yan po yung common mistake. Akala yung 30 points, ayun na din yung percentage. Hindi po. Okay? Yan po, to convert into percentage, lalagyan po natin ng decimal point sa una. 0.30% carbon. Okay? So, if you take the total nung dalawa, 3 and 30, 3 and 0.30, that is 3.30% lamang. Okay? So, see that as compared to the percentage of yung pong atin na iron, kukunti lang po talaga siya. Traces lang po talaga siya. Okay? So, ganyan po natin ina-identify or ini-interpret yung designation po. Okay? So, how do you evaluate this or how do you interpret this one? This is a nickel steel with approximately 3% of nickel and 0.30% of carbon. Okay? So, ganun po natin siya babasahin. Kaya dapat po alam natin yung mga type ng steel, yung codes na ginagamit. So, the same thing kapag po SAE. So, may SAE po tayo. Kung mabasa po natin, halimbawa ay SAE 2330. Okay? Pag SAE 2330 po, ganun din po yung interpretation niya doon sa AISI. So, ibig sabihin, we assume that these two po, okay, these are just the same materials having the same properties kasi parehas po yung kanyang composition. Okay, kumbaga magkaiba lang yung manufacturer niya. One is AISI, the other one is the SAE. Okay, so yun lang po yung pinakaiba. Now, for the AISI, meron po tayong dinadagdag na suffixes and prefixes. Okay, these are group of letters o kaya pwede din naman na single letter na dinadagdag natin before or after po yung 4-digit na number. Okay, so it is only the AISI na meron pong ganon. Okay, halimbawa po ay AISI B2320 o kaya naman ay AISI 2320H. Ayan. So, kapag po may ganyan, it can be a single letter, okay, before the number or single letter after the number. O kaya din naman, it can be a group of letters, say 2320 WQT. Yan, okay? So, ito naman, group of letters. So, yung si SAE po, wala ganyan. Okay? Yun lang po AISI ang naglalagay po niyan. Okay? So, ano pong ibig sabihin ng mga ini-insert natin ng mga letters na yan? Anyone? Hello? Ano pong ibig sabihin ng mga ini-insert natin na letters on this AISI coding? Anyone? Naririnig pa po? Yes. Sir Dan?
Ma'am, ang tanda ko lang po ay dun po sa WQT, which is yung water quench tempered po. Parang ano po sila manufacture po sa letters po.
Okay. So, yung sinabi ni Sir Dan is the meaning of this WQT. Tama po yun. Water quench tempered. But in general, yung lahat po ng letter na idinadagdag natin before and after the number, okay, it defines the processes. Okay? So, kanya-kanyang letter, may kanya-kanyang process. Okay? Na in-incorporate doon sa or pinagdaanan nung ating steel na yun bago siya magawa. Okay? So, yun po yung ibig sabihin ng kada letter po na yun. Again, it defines the processes na in-undergo nung material. Okay? Just for example, katulad nga nito, WQT, water quench and tempered. Meaning that this material, okay, water quench, nilublob, binabad natin doon sa medium na yon to water at a desired temperature, kaya tempered. Okay? So, WQT. QT. Okay, minsan naman OQT, meaning you have a different medium naman, oil. Yang ibig sabihin. Okay, so sana ay alam natin kada letter na ilagay dyan. Okay, so that if we are evaluating the material, alam natin anong process yung ko po niya. Okay, so kung i-compare natin si AISI with SAE, mas detailed po si AISI kasi kinukonsider pa niya or sinasabi pa niya yung process na pinagdaanan. Not unlike
Ma'am, excuse po, parang nag-choppy po kayo. Thank you po.
Naririnig na? Okay. Saan ako tumigil? Yan nakalimutan ko. Saan ako nawala kanina? Ha? Okay. So what is the difference between the AISI and yung SAE? Okay, so katulad nga sabi ko kanina, parehas lang po yung 4 digit. Okay, so we assume na parehas yung composition niya, so parehas yung properties niya. Mas detailed nga lang si AISI kasi dinidefine pa niya, okay? Dinidefine pa niya yung process na in-undergo nung material. Okay? Pero from this, you can identify now the properties of your material. Okay? So, of this code, pinaka-useful po na tinitingnan natin dyan is yung last 2 digits, right? So, from the points of carbon, you are able to classify whether the given code or the given material is ductile o kaya po ay brittle. At ito po yung pinakamahalaga sa design. Okay? First thing that you should do is to classify kung siya ba ay ductile or brittle. Kasi it is different to design ang material kapag siya ay ductile at saka po siya ay brittle. Okay? So, iba yung nagiging basihan po nila, okay? Kapag po ductile at brittle. Kaya ang titingnan po agad natin is yung dalawang huling number which defines the points of carbon. Okay? So, pag sinabi po natin ductile, yan po ay low and medium carbon content. Okay? Kapag po naman brittle, yan po ay high carbon content. Okay? So, ang titignan po natin yung dalawang huli. Okay? So, doon po tayo sa 50. So, if it's 50 and below, nandito po siya sa low and medium. Okay? And then, if it is above 50, yan po yung high carbon content. Then, you can define po whether this material is ductile or brittle. So, pag nakita mo po ay hanggang 50 siya and below, so that would be ductile. Kapag po siya ay more than 50, then that is a brittle material. Okay, so to classify this 2330, so ano po siya? Ductile po ba o brittle? Yes, Jericho.
Ductile po. Ductile po.
So, this would be a ductile material, okay? Because it contains 30 points. Okay, correct. So, since it contains 30 points of carbon. Okay? Hello, narinig pa po ba?
Yes po, dinig po.
Narinig pa po na ako?
Yes po, ma'am.
Parang
Dinig.
delay kasi yung ano. Hello? Alma, narinig pa ako? Ha?
Ako, ma'am, dinig po.
Ang choppy.
Diyos ko, paano
Okay na?
ang bata ang ating
The next slide, okay? On the next slide, okay? You have there 1 to 12, okay? So, let us identify now whether the given material is ductile or brittle, okay? Hello?
SCIXX was the meaning of the first X.
Okay, good. Okay, good. So, i-identify po natin. So, I will call on names po from 1 to 12. Okay? From 1 to 12.
And the next number is the
Okay, and then you define po, okay, kung siya po ba ay ductile o brittle. Okay? So, the first one, okay? So, AISI C1095, dormant.
Ma'am, excuse po, nakamute po ako.
Okay, so let us have first, yes po. Okay na, pakinig na.
Opo, ma'am, thank you po.
Tingin niyo ang table.
Okay na?
Yes po, ma'am.
Okay, good. So we have here listed our different materials using the code. Okay, so let us now define whether this material is ductile or brittle. Okay, so I will call on names and then paki-identify na lang kung ductile ba siya or brittle. Okay, let us start with number 1. Okay, let us have first Ayari.
Hello po, ma'am. Yung one po is brittle.
Brittle. How many points of carbon?
95 po.
95 points of carbon, and then in percentage,
Yung pong 10.
anong percentage ng carbon? Hello?
0.95 po, ma'am.
Tama, 0.95% of carbon. Okay, number 2, ductile or brittle? Aldrich.
Ano po, ma'am? Ductile po.
It is a ductile material. So, yung 50 po is considered still a ductile material. 3, Miss Angela.
Ductile po, ma'am.
It's a ductile material. 4, Carlos Miguel.
Ductile po, ma'am.
Okay, 5, Justin.
Justin, ano po?
Justin? Okay, ikaw na. Ikaw na nagsalita
Ano po?
game.
Ductile po.
Okay, number 5 is a ductile material. Number 6, King Russell.
Ma'am, brittle po.
Okay, 6 is a brittle material. 7, Phil.
Ma'am, ductile po.
Ductile material. 8, Rose. Rose, number 8.
Ductile po, ma'am.
It's a ductile material. 9, Isa.
Ductile po, ma'am.
Okay, 10, Rip. Okay, 11, Ralph.
Ductile po, ma'am.
And then last 12, Kurt.
Ductile po, ma'am.
Kurt?
Ductile po, ma'am.
Okay, it's a ductile material. Okay, so with this 12, you are able to define, okay, whether it's ductile or brittle using po the given code. Okay, so let me go back po dun sa slide natin kanina. Okay, again, so yung inano po natin is by the code. Okay, so you are able to know the property of the material based on the code and classify whether it is a ductile or a brittle material. Okay, yung pangalawa naman po, know the property of the material as to the strength. Okay, so as to the strength, you should be able to define whether yung ano po yung material natin, ano yung kanyang ultimate strength. Okay, at ang isa po is yung yield strength. Okay, so given po yung code, hahanapin po natin ano yung kanyang ultimate strength at ano yung kanyang yield strength. For the ultimate strength po, we use the symbol sigma and then subscript U. For the yield strength naman po, it would be sigma Y. Okay, so yan po yung mga symbols po natin. Okay, can you remember po, how do we define an ultimate strength? So ito po ay diniscuss natin when we have the stress strain diagram. O, alin po yung tinatawag natin na ultimate strength? Anyone? Yes, Sir Dan?
Yun po yung pinakamataas po na strength po na kayang i-reach ng isang material.
Okay, so ito po yung pinakamataas na strength na kayang i-handle ng material without the fracture. Okay? So, sa ating pong stress strain diagram, ito po yung pinakamataas na point po. Okay? Yun po yung ultimate strength. What about po yung yield strength? Alin naman po yung yield strength? Any other? Hello? Yes, Alma?
Bali, ang yield strength po is yung ano po, yung maximum stress po ng material before plastic deformation po.
Okay, so it's the maximum stress before the plastic deformation. And what do you observe for this yield strength? Okay, so di po ba ang ginagawa natin, you have the material, pag niload po natin siya, say for example, a tensile strength, it will have its corresponding deformation. Okay? But then, pag inalis po natin, yung load na in-apply, ano pong nangyayari? Nawawala din po yung kanyang deformation. Tumitigil din po siya sa pag-deform. Okay? So, ang ano po ang nangyayari dito sa atin na yield strength? Yes, Alma? You're raising your hand? Hello?
Sorry kung napindot lang po. Medyo mabagal lang pwedeng internet.
Okay. So, doon po sa sigma y, okay, ang nangyayari po doon, kahit po wala tayong ina-apply na load, okay, the material continuously deform. Okay, nag-elongate siya kahit hindi ka na nag-increase. Okay, so yun po yung nangyayari kapag doon sa yield strength. So dito po, ito po ang hahanapin natin sa design. Okay, this two po, ultimate strength and yield strength, this will be the basis of our design. Okay, so we will be designing based on the ultimate strength o kaya naman po designing based on the yield strength. Kaya dapat po makita natin yung values ng dalawa. What would be the value of sigma u, what would be the value of sigma y given the material, given the code. So saan po natin yan makikita? We will be using our design tables. Okay? So paano po yun? Halimbawa po, we are given AISI C1020 as road. So ito po yung sample, okay? So with this is your yung code, okay? From the code po, hahanapin naman natin sa table ano yung value ng ultimate strength at ano yung value ng yield strength.
Orlando mo na eh.
Pag-focusing yan, okay na. Okay, so i-close po itong aking PowerPoint. Okay, kunin nyo po yung inyong design tables. Tapos doon po tayo ngayon. Okay, yun po yung ipipresent ko. Wait lang po. Okay. You have your tables with you na pa? Hello?
Yes po, ma'am.
Okay. So, yung sample po natin kanina, okay, is AISI. Wait lang. Okay. So, yung sample po kanina is AISI C1020 as row. So, ang hahanapin po natin is sigma u and sigma y value. Okay, punta po tayo din ha. Table 87. O buklat po yung ating design tables. Dini po ang punta. Table 87. Yan. So, using this table po, okay, hanapin po natin yung hanay ng AISI number. Okay? So, hanap po yung C1020. So, we have here po yung C1020. So, apat po yung nandinin na entry ng C1020. And then afterwards po, you have here po the condition as row. So, ito po yung condition, ito po yung as row. So, ibig sabihin, ari po yung kailangan natin, C1020 as row. Then, we find value of the ultimate strength and the yield strength. Okay? So, ito po yung ultimate strength at ito naman po yung yield strength. So, dyan po, ang nakalagay po natin ay SU at SY, lumang libro. Okay? But then, definitely, we will be using here sigma U and the other one would be sigma Y. O, paalala lang po, wala pong magsusulat doon sa design tables. Ha? Oh, hindi po i-allow during exam kung may sulat po yung design tables. Kaya pakinggan na lang po. Okay? So, this is sigma U, sigma Y. Okay? So, C1020 as rolled. Alin po yung sigma U niya? 65. Okay? Alin po yung sigma Y? 48. Okay? So, sigma U is 65 and sigma Y is 48. Ano pong unit? You have their KSI. Okay, 65 KSI, 48 KSI. Okay, KSI is kips per square inch. Okay, and when you say 1 kip, that would mean kilopound. Okay, so it's equivalent to 1,000 pounds. Okay, so kung meron po tayo ditong 65 KSI, equivalent po niya is 65,000 PSI, pounds per square inch. Okay? Now, yung pong values natin, these are the strengths of the material, sigma U and sigma Y. Kung kinuha po natin yan doon sa table, okay, pag ginamit po natin yan, lalagay mo po pala parati yung reference kung saan natin siya nakuha. Okay? So, ilalagay po natin, this is taken from table 87. This is page 14. Okay? So, this is taken from table 87, page 14. So, I observe po yung mga ganyan sa inyong solution. Okay? Parte po yan ng solution to include yung reference table or figure na ginamit. Pag wala po nakalagay na ganyan, yung reference table at saka po yung page number, it would mean po na kinopya mo lang yan doon sa iyong katabi o sa iyong kaklase. Okay? So, it will be marked wrong. Okay? Kaya lagi pong may kasama pong ganyan lahat ng inyong solution. Okay? Pag gumamit po tayo ng table, may kunuha tayong data sa table, lagi nyo pong ilalagay yung reference. Okay? Ano pong page at ano pong table number or figure number po. Okay? Nakuha po ba? Nasundan po?
Yes po, ma'am.
Okay. What if naman po, you are given there SAE 1020. Yan. SAE 1020. Okay? So, pag SAE po, dito po, kahit po buklatin natin lahat yung tables dyan, okay, yung pages dyan, wala po dyan na SAE. Okay? Mostly po yan ay AISI number. So, kung ang given material po is SAE 1020, okay, doon mo rin po siya titingnan sa AISI 1020. Okay? So, ibig sabihin, ito ding apat na ito ang ating pamimilian. Okay? Kasi nga, hindi naka-define sa SAE kung anong process yung ina-undergo niya. Kaya minsan, wala talaga letters na naka-indicate. So, alin po ngayon, ma'am, ang pipiliin ko din ay apat po yung sa 1020. Okay? Alin po yung pipiliin? So, kaya nga sabi ko sa inyo, sa design, meron kang freedom din kung alin doon yung pwede mong gamitin. Okay? Kaya sabi ko, ay huli dito kung sino yung nangongopya lamang. Okay? Maaaring yung pinili mo ay hindi katulad ng pinili niya. Pero kung buong klase kayo na yun yung pinili, ibig sabihin there is something wrong. Not unless may minention ako kung alin yung dapat gamitin. Okay? So, lahat yan ay pwede po natin gamitin. Okay? But then, halimbawa, we set yung rule. Alin po yung gagamitin natin? Pare-parehas po yan. So, for us to arrive at only one answer, pwede pong i-declare natin, say, let us make use of the maximum value. Okay? Alin ba yung may pinaka mataas na value? O, yun pong nasa dulo. Okay? So, you can say, assume, okay, cauldron, and then you'll have, say assume cauldron, and you'll have the value your sigma u would be equal to 78 KSI, and your sigma y is equal to 66 KSI. Taken from, again, table 87, page 14. Okay? So, ganun po yung gagawin natin. Maliwanag po ba?
Yes po, ma'am.
Nakuha po? Naintindihan ba? Okay. So, hindi po yung table 87, hindi po dahil ito lang yung sample ko, ay di nilang sa table 87 natin kukunin. Okay? So, yung mga properties po na yan, pwede po kunin natin sa ibang table. Okay? Kung saan po natin makikita yung binigay na AISI number. So, buklatin po natin dyan. We have table 88, 9, 10, and so on. Aside from the tables, pwede rin pong gamitin natin yung mga figures po dyan. Okay? Kung saan makakakuha tayo ng values ng sigma u and sigma y. So, pakibuklat-buklat po natin. Okay? Now, ibabalik ko po doon sa kaninang listing ng mga materials. Okay? And yung pong 1 to 12 kanina, ibabalik ko po doon. Tapos, ang gagawin nyo po, hanapin nyo po kada isa yung kanilang sigma u at saka po yung kanilang sigma y using our tables po. Okay? So, yan po yung ating first activity. Familiarization noong mga design tables po natin na gagamitin. Okay? So, I'll stop po ito. Balik ko po doon sa kanina. Yung 1 to 12 po. Yan, okay? Ari po yung 1 to 12 kanina, okay? So, sa kada isa po, hanapin po natin yung sigma u and sigma y. So, ang unahin nyo pong ilalagay yung code. Halimbawa po, AISI C1095 normalized. Yan. Tapos, kunin nyo po, yun po yung code, anong value ng sigma u, ng sigma y. And then, taken from the reference table, number, and then, ano po yung page number. Okay? So, ganun po ang gagawin dito po sa 12 yan. Okay? So, hanapin nyo po dyan kung saan nyo makikita dyan na tables or figures, makikita itong mga materials po na ito. Okay? Naintindihan po ang gagawin?
Yes po, ma'am.
Okay, and then I will be sharing to you po yung ating Jamboard. Doon po natin i-paste yung ating mga sagot. Okay? Lagyan lang po ng pangalan. Okay? Sige po, you can start na po. And then later po, i-review natin yung mga sagot po ninyo. Okay, shared to you is the link of the Jamboard wherein you can post po your answers to this exercises. Okay? Pakilagay na lang po doon yung po natin, sagot natin. And then, you take note po of those numbers na hindi nyo sigurado yung answer natin. Okay? Kung paano ba kinuha. Okay? Meron po kasi dyan, directly lifted lang doon sa yung or directly copied lang yung value na niya doon sa tables natin. So, ika-copy lang po iyon. So, ganun lang po kasimple. Meron naman po na medyo nakakalito, kaya yun po yung tatandaan natin na numbers at yun po yung i-discuss natin. Okay? So, ilagay po natin yung answers natin doon sa Jamboard po. Okay. Nakikita po yung mga materials na to. Alam ko kung saan kukunin yung mga values. Hello?
Tomorrow, Seb.
Yung iba po ma'am,
Hindi yun yung tangay, Edo. Ibang subject ang pangay, Edo.
Okay, I think it's time na. 4:30 until 4:30 nga lang tayo. Tama ba?
yes po.
Alma?
Yes po
Okay,
ma'am.
so sige. You may continue po working on it. Paki-post na lang po dito sa atin na Jamboard para pwede nating balikan. Okay, next meeting po natin. Okay, so I'll, i-close ko na po itong